Hello students, in this video we will be learning about the Gaussian density function. Gaussian probability density function. So a PDF is said to be Gaussian if it is in the following manner, where f of x equal to 1 by root 2 pi sigma square under the root only, e power minus x minus a whole square by 2 sigma square, where x is from minus infinity to plus infinity. If the PDF is in this format, that is called Gaussian PDF. Very important. Number of times the questions came, and from the solution of this Gaussian PDF, number of times. Let's see. Here, if I draw the graph of this, it will be in the following manner. It is symmetrical about that point A, that A itself is called mean. I will tell you one more time. This is the shape of a Gaussian PDF. Maybe human errors will be there. It's approximately the shape of like that. Versus x, this is the PDF f of x. So, here it is symmetrical about A, that A itself is called, student, mean of a Gaussian random variable. That A itself is called mean. And what is the sigma square now? That sigma square itself is called variance. Variance is nothing but sigma square. Then what is the mean square value? Try to see. What is variance formula actually? M2 minus M1 square na? Then what is M2 equal to? Try to recall. M2 equal to sigma square plus M1 square, where sigma square M1 is given a square. That is called their mean square value. And variance we got means standard deviation is root of variance. This term, this sigma square is called variance. And here it is symmetrical about this point. If anyhow PDF is symmetrical about any point on along x-axis, I told that symmetrical point itself is called their mean value also. Now here, this is symmetrical. So this is symmetrical means this area is equal to this area. So total probability, total area under the PDF is 1. So this area equal to 1 by 2. This area is also equal to 1 by 2. For example, can you say, what is this probability at x equal to a? At a single point x equal to a, what is the probability? Yes, its value 0. Why, sir? Probability of a continuous random variable at a single point is 0. Or if you want, how to calculate probability from PDF? Integrate. From where to where we have to integrate? A to A only. Because at a single point we have to integrate. Because I want at single point. Single point integration will be 0. Then what is the probability of x less than or equal to a? Or maybe probability of x greater than or equal to a? Both will be half of means. Half area means 1 by 2 because total probability is 1. For this Gaussian random variable, we need to calculate the solution for this. There are two ways of calculating solution. One is the simplest solution by taking mean value 0, variance value 1. And another one is we can calculate for general whatever may be the mean and variance. We will bring a common function, and we are having that common function is called Q function, and we are having Q function tables. Any standard textbook of communication, from the table we will take the value. So before that, if this is a small, then what about the capital? Capital F of x is nothing but integral minus infinite to x f of x. That is 1 divided by root 2 pi sigma square into e power x minus a whole square by 2 sigma square into dx. This is the density function. This is the distribution, cumulative distribution function. Now I will calculate the solution in two cases. The first case I will explain here. That is the simplest solution by taking mean value 0 and variance is 1. If I take mean value 0 and variance is 1, then how the density function is becoming? Density function f of x is nothing but 1 divided by root 2 pi sigma square value is 1 e power minus x square by 2. 2 sigma square value is 1, so 2. Mean value 1. So what is, we have the condition, the total area under the PDF is 1. So integral minus infinite to plus infinite 1 over root 2 pi into e power minus x square by 2 dx value is 1. Very important. Number of gate problems are there based on this. So integral minus infinite to plus infinite 1 over root 2 pi e power minus x square by 2 into dx. This is this value. Of course, this is a solution for the simplest solution for Gaussian random variable by taking mean value 0 and variance is 1. Now we will take for general values of mean and variance and we will bring the common function in terms of Q function. Let's see. Continue that. We've seen the simplest solution. Now we will see the general solution. For the Gaussian PDF, what is the distribution function? Distribution function is fx of x equal to integral minus infinite to x 1 divided by root 2 pi sigma square into e power minus of x minus a whole square by 2 sigma square into dx. This is the distribution function of a Gaussian. Now, what I am doing is, let us consider x minus a by sigma equal to some dummy variable y. Then see how it is going to be varied. Integral, or first I want to write this 1 divided by root 2 pi sigma square. I am writing out. Follow. Integral. I want to calculate the lower limit for y. How? Substitute the lower limit of x. If we substitute minus infinity minus a, minus infinity by sigma, minus infinity only. What is the upper limit for x? Is x only. So in place of x, replace x. So x minus a by sigma. This I already written outside. This is nothing but e power minus y. So y square by 2. What is dx equal to? Differentiate on both sides. If you differentiate, sigma comes this side. So dx and a means constant 0. So it becoming as a sigma dy. Here sigma, here root of sigma square, both will be cancelled. What is remaining, sir? 1 divided by root 2 pi into integral minus infinite to x minus a by sigma into e power minus y square by 2 into dy. Getting my point? Now, fx of x, we got 1 divided by root 2 pi into minus infinity to x minus a by e power minus y square by 2 into dy. We are bringing this one in a general form, that is the Q function. For example, what is Q of alpha value? Just a dummy variable. Changing that rather than taking x, I take another variable. Or if you want, I can also take Q of x equal to, what is this formula? 1 divided by root 2 pi into integral minus infinite to x e power minus alpha square by 2 into d alpha. Where here alpha is some dummy variable. Always, I written I think in reverse manner, 1 second. Sorry. X to infinity. Always the argument of a Q function is equal to its lower limit. Argument of a Q function is equal to its lower limit. And another thing we need to understand that Q of x value decreases as x value increases. Q of x value decreases as x value increases. And one more point we need to remember, q of minus x value is nothing but 1 minus q of x. Q of minus x value is 1 minus q of x. Q of x lower limit is, argument is nothing but it's a lower limit. Now, let us consider this is expression 1. Now follow. What is the another modification I am doing in that one is, that is fx of x. In that one, what is the modification I am doing is, I am taking another dummy variable. Here I am taking another dummy variable, for example, y equal to minus p. That is a transformation I am doing. Follow. 1 divided by root 2 pi. What is the lower limit for y? Minus infinity. What is the lower limit for p? Minus infinity equal to minus p. Minus minus plus infinite. What is the upper limit for y? X minus a by sigma. What will be the upper limit for p? Minus of x minus a by sigma into, this is e power, replace y with minus p. Minus p square also p only. So e power minus p square by 2 into dy. What is the dy? Minus dp. Are you getting my point? To avoid that negative sign, I can interchange the limits. So, because upper minus lower limit, if you write lower minus upper, minus difference, that minus minus gone. 1 divided by root 2 pi into integral minus of x minus a by sigma infinity. Exchange the limits. E power minus p square by 2 into dp. This is the expression number 2. This is fx of x. Try to compare expression number 1 and expression number 2. Try to compare q function value with fx of x. That is the distribution function of a Gaussian function. If you compare expression 1 and 2, students, what I told, this is nothing but same q function, but a q function argument is its lower limit. Don't bother about here p, here alpha, both are dummy variables, because after substitution those will be vanishes. So that's why dummy variables. This is nothing but 1 minus q of x minus a by sigma. This is fx of x. This is the relation between Gaussian distribution function and a q function. Of course, the solution for that. Of course, here what is a called, student? A is called mean value, sigma is called standard deviation. So, for anything, if you want to calculate, sir, for any value of x we need to calculate, we will substitute here, some q function value will come. So, how we will get the q function value? Q function value will get from the q function table. That we will get from the q function table. Clear?